Good morning, everyone, Nana.
Good morning, sir.
Good morning, sir.
Good morning.
Good morning, sir.
Yes, good morning. Now come to here. Yesterday, what we discussed?
Sir, alpha, beta, gamma rays.
Emission, I explained, I think.
Sir, deflection in magnetic and electric fields, sir.
Okay. Right. Means properties we discussed. Alpha, beta, gamma rays.
And sir,
How they are influenced by electric and magnetic fields, penetration power, and all. Okay, after discussing the properties of the radioactive rays, good morning. We have to come to here. Suppose those radioactive rays, while coming out of the substance, what happens? Okay, due to the emission of radioactive rays. Like alpha, beta, gamma rays. What happens? Why it is the substance is the nucleus is emitting the radioactive rays here? What is the reason behind? Because it is
Heavy.
unstable.
To attain stability.
Not only heavy, it is unstable and trying to attain the stability. Okay. So due to the emission of radioactive rays, what happens? The unstable nuclei are transforming into stable nuclei. Means if you give more time, then you can find out in the whole substance, the number of unstable nuclei decreases, the number of stable nuclei increases. Now you understood this point, Nana?
understood, sir.
Understood.
The unstable nuclei are converted into, better we say disintegrated. That is the correct word here in our physics. Are disintegrated to unstable nuclei. Means over a period of time, you can see that the unstable nuclei decrease, and the stable nuclei increase. Means number of unstable nuclei decreases and the number of stable nuclei increases. Okay. This phenomenon of transforming the unstable nuclei into stable nuclei is called as disintegration. Okay, this phenomenon is called disintegration. Okay, means what he is saying, suppose initially I take 10 power, say, or else you take some number like say some 3000 nuclei I took at an instant t is equals to 0. These 3000 is what? try to remember they are unstable nuclei, number of unstable nuclei. Okay, that number, initial number, whatever you are taking in a substance, the number of unstable nuclei would represent, before starting observing this disintegration phenomenon process. Okay, initially how many number of unstable nuclei are present in a substance, we represent with the letter N0 nana. That's what I'm taking here. I write the number of unstable nuclei is equals to N0 I'm taking at T is equals to 0. Now my question is, if I give some time here, this N0 decreases or increases?
Decreases.
Decreases, sir.
Yeah, that's what I'm saying. The number of unstable nuclei equals to N after a time T is equals to T. Certain time I gave here. Over that period, N0 decreases to N. Okay, so here you have to remember N is less than N0. Means that N number of nuclei instant to instant gradually decreases at certain rate. That rate, next point I'm writing here, rate of disintegration as dN by dt. Since that rate gradually decreases, why? Because unstable nuclei decreases. That's why I represent here with minus dN by dt. Negative sign indicates that the disintegration rate gradually decreases when the unstable nuclei decreases. Now you understood this point, Nana, why I put the negative sign there?
Yes, sir.
Is it clear? Right, good.
Rocket
And this rate of yes, rocket propulsion కూడా same ఇదే type లో we take. There we take minus dm by dt. Mass
Yes.
there decreases. Directly proportional to the mass present at that instant. In the same way, here I write next one. This rate of disintegration minus dN by dt depends on whom? I say in the same way rocket propulsion, the mass present at that instant. Here it depends number of nuclei present at that instant. So directly proportional to N. Don't take N0 now. N0 is initial number. Okay. Then you have to come to here. That N value after certain time, how much? Means we are trying to derive that part. That implies I write minus dN by N. Okay, better I write first the proportionality constant. Okay, right here. Minus dN by dt is equals to some constant into N. That constant is represented with lambda usually. That lambda is what, sir? Here proportionality constant in disintegration. That's why it is called as disintegration constant. It depends on whom, sir? Depends upon the nature of nuclei. Okay, it depends on, simply I write like this. It is different for different nuclei. Okay, nuclei in the substances. Better I write how Nana it is different for different substances. Better I write different elements. This is a good word. Different elements. Okay. My intention is for uranium, for thorium, for plutonium, all are radioactive elements, Nana. The lambda is not same. Now you understood what is the meaning of this one?
Yes, sir.
Yeah. Right. Even for isotopes also it will be different. Means uranium 235, uranium 238. Sorry. Correct. Isotopes. Uranium 235, uranium 238. They don't have same lambda, Nana. Okay. So element is changed by changing either Z or A. The disintegration constant also will be changed. Okay. So this is disintegration constant, and here
Sir, it is elements or nuclei, sir?
న్యూక్లియై ఇన్ ద ఎలిమెంట్స్ కదా నాన్న.
Okay.
ఎలిమెంట్ మారిందంటే న్యూక్లియస్ స్ట్రక్చర్ మారినట్టుగా.
Yes, sir.
అర్థమైందా? ఇప్పుడు యురేనియం 92-235 అన్నాం, యురేనియం 92-238 అన్నాము. ఇప్పుడు బోత్ హ్యావ్ సేమ్ న్యూక్లియై నా? డిఫరెంట్ న్యూక్లియై కదా.
సార్ నేను
చెప్పండి మాస్టర్.
N/Z చెప్పారు సార్. గ్రేటర్ దెన్ 1 అంటే రేడియో యాక్టివ్ అలా దాని మీద ఉంటుందా లాంబ్డా?
కాదురా, ఇప్పుడు యురేనియం 92-235 వన్ ఎలిమెంట్, రేడియో యాక్టివ్ ఎలిమెంట్. దిస్ ఇస్ అనదర్ రేడియో యాక్టివ్ ఎలిమెంట్. అంటే ఇన్ దిస్ న్యూక్లియస్ దేర్ ఆర్ 92 protons, there are 235 minus 92 neutrons. Okay, according to Aryan's method. So here there are 92 protons and there are 238 minus 92 neutrons. అంటే are these two nuclei equal అంటున్నాను నేను అనేది అది. రెండు ఈక్వల్ ఎట్ అవుతారా? దీంతో కంపేర్ చేస్తే హియర్ వీఆర్ ఫైండింగ్ అవుట్ 3 న్యూట్రాన్స్ మోర్ ఆర్ నాట్. కాదా? హియర్ నో వన్ ఈజ్ రెస్పాండింగ్.
నాట్ ఈక్వల్ సార్.
Understood,
మరి
sir.
దే ఆర్ నాట్. మరి హియర్ ఓకే. సో హియర్ ద ఎలిమెంట్ ఈస్ చేంజ్, న్యూక్లియస్ ఈజ్ ఆల్సో విల్ బి చేంజ్. ఇంకా అందులో అడిగేదే ఉంది క్వశ్చన్. ఓకే.
Okay,
So this is the lambda. Right, this is the lambda, and here minus dn by dt. Finally, I got one equation. Okay, usually in few problems directly we can use this formula to find out something. So better we remember this is one formula here. And then here next what I say, if I require the value of n after certain time, I need some integration here by rearranging the terms there. Here next I write that implies minus dn by n is equals to lambda into dt. On integrating both sides, next step minus integral dn by n is equals to lambda integral dt. This one no need to explain, all of you know that minus log n, and here this is lambda t. Now we have to substitute the limits. In a time sum 0 to t, n value at the time t equals to 0, I am finding out the n naught. N naught to n. At the time t, n is equals to n. That n I require. So I will write here this is log n by n naught is equals to minus lambda t. Is my substitution correct, Nana?
సరే n నాట్ బై n
Log
కాదు
n
సార్.
minus log n.
సార్ మైనస్ లాగ్
Minus
పవర్
by
అవుతుంది కదా సార్.
మైనస్ I took to the other hand కదరా, ఏం చూస్తారు?
ఓకే ఓకే
Correct,
సార్.
sir.
కరెక్ట్ సార్.
Minus lambda t. ఓకేనా? So here I write n by n naught equals to log means e power minus lambda t. This is base e, Nana. E power lambda t. That implies in the next page I am getting the equation for n, number of elements at a certain instant. Okay, of course you can easily remember this formula. N is equals to n naught into e power minus lambda t. What is the complexity here? We can easily remember. But my question is, n is what?
n is
Number of unstable nuclei.
Number of unstable nuclei. Okay. ఇప్పుడు for example, if they ask after a time t, the number of unstable or undecayed Undecayed means not yet converted into stable. Undecayed nuclei present in the substance. Is equals to how much you say?
N is equal to N naught into 1 minus e to the power of minus lambda t.
N equals N into N naught into
1 minus e to the power of minus lambda t.
1 minute, Nana. Okay, sorry. Here, N, what you are saying, Nana, here?
N is equal to N naught into 1 minus e to the power of minus lambda t.
Means you are saying that it is N naught minus N. Am I right?
Yes, sir.
But I think it is not correct.
Wrong, sir.
It is wrong, ra? Why? Because unstable means మరి ఏం అబ్జర్వ్ చేస్తున్నారు? The number of unstable nuclei itself is N only. ఇది ఎలా అవుతుంది? So is it N naught minus N or N?
N, sir.
N, sir.
ఇది N. Okay. అంటే out of 3000 at t is equals to 0. Suppose after 2 seconds or 3 seconds I found 1000. This 1000 is unstable అంటున్నాను. Means undecayed nuclei. This 1000 is unstable nuclei. In that 3000, 1000 still there unstable అంటే how many converted into stable?
2000.
2000.
That one. If I ask the next question here, after a time t, the number of stable or already converted into stable, that is decayed nuclei, if I ask, okay, present in the substance, they won't escape into the space. They present in the substance only. Present in the substance. This one is 3000 minus 1000. You can do. That is 3000 is initial number N naught minus 1000 is a still undecayed. That is N. Idi every year we are finding out a small confusion in the minds of students, Nana. That's why what aim adugutunnadu, what he is asking the examination, look at and try to say the answer. What he is asking, undecayed or decayed? Question kasta neat ga patience unsukoni kasta chudandi question what he is asking. Okay, observe there. If he asks unstable, then try to find out N from this formula. If he asks decayed nuclei, already decayed nuclei, then after finding out N, take N naught minus N. Numericals చేసేటప్పుడు I think you won't do any mistake here after explain. Right, good. Take care while solving the numericals. I am not responsible. Already I explained here how to find out the stable and unstable and stable. Okay. Again, I am moving back to my theory here. Sir, what will be the unit of this dN by dt, sir? dN by dt, when you come to numericals, they give it as unit disintegrations per second. And that's it, Nana. Okay. So here we say dN by dt unit is disintegration per second. This is dN by dt. Lambda, I think no need to say. From here you can say dN by dt disintegrations per second means lambda unit will be just per second. Keep in mind. N is number of nuclei, Nana. Okay, so unit is just per second. Okay, when you see the numericals there, you can find out all those things, Nana. Right? And here, sometimes this dN by dt is called as activity, disintegration rate. So next point, what I'm saying, the disintegration rate means the rate of disintegration. Better I write like this. The rate of disintegration, that is minus dN by dt, is called sometimes as activity. Means what I'm saying, minus dN by dt, I write it as A, Nana. Okay, if I write it as A, if they ask in exam, find out the activity of some radioactive substance, directly I use dN by dt is nothing, minus dN by dt is A is equals to, directly I write dN by dt formula, lambda into N. Okay, or I can write minus dN by dt, which is nothing but activity, is equals to lambda into N is nothing but N naught into e power minus lambda t. I write. Now you understood, Nana, this one?
Yes.
sir.
Okay. Right. So when they ask the question related to activity, you try to use this formula here. Okay. This is activity. And here, suppose he says the initial activity and final activity after certain time. Okay. Initial activity means what, sir? That N naught also changes that. Suppose the initial number of nuclei changes, the initial activity, next point, is represented by A naught. Then we write A naught, we write it as, actually according to the same formula, okay, minus dN naught by dt. Am I right, Nana?
Right.
Okay. Right. This one I write it as in the same way like this one. I write it as lambda into N naught. Here, A is equal to, after certain time, A is equal to lambda N. Initially, A naught is equals to lambda into N naught. Okay. Now you can compare these two, Nana. The above pink color box and the below pink color box. This one. Okay. If you divide the two things here, that implies I can write here A by A naught is equals to, by dividing lambda cancel, I will get N by N naught. Okay, that implies A by A naught is equals to, here if I substitute N in place of N naught into e power minus lambda t, N naught get cancelled, I will get e power minus lambda t. Is it correct, Nana?
Correct.
Yes, sir.
That implies activity equation I'm getting here, A is equals to A naught into e power minus lambda t, identical to N is equals to N naught into e power minus lambda t. So even you can use this equation when you come to numericals. Okay, A is equals to A naught into e power minus lambda t. If they ask activity after certain time by giving the initial activity. If they ask number of nuclei, the two undecayed nuclei after certain time, you can go to this pink color box, this box. Okay, any confusion here, none in my explanation?
No, sir.
No, sir.
Every point is clear
Clear,
in
sir.
the first page and second page? Right, good. Then here, if they ask, what is here the number of nuclei present? Okay, sorry. What is the time taken to decay to half of the present nuclei? That is called as, means you are doing what simply. Next point.
N is
The
equal to N
initial-
naught by 2.
That's what I'm saying. The initial number of nuclei, undecayed radioactive nuclei, is equals to N naught. And here, after a time t, the number of same radioactive nuclei is equals to N naught by 2. Exactly made half to the initial number. Okay. Then the time t will be called as, do you know that now? I think you know it.
Half-life.
Here time t is called half-life time. Okay, that is represented, that implies t is equals to t half. T half represents half-life time. What is the advantage of this half-life time, sir? After this half-life time, if you see, that implies after one half-life time, you can see there the number of undecayed nuclei, that is equals to number of decayed nuclei. Any wrong in my statement, Anna?
No wrong.
After
No,
Correct,
sir.
sir.
No, sir.
That's simple. Out of 3000, 1500 decayed means 1500 undecayed. Okay. So both are equal to N naught by 2. Okay. So they may ask, after how much time the undecayed nuclei is equal to decayed nuclei in a substance? Indirectly also they may ask. Means indirectly he is asking what is, find out the half-life time. Okay. That's why I gave this point. So keep in mind this point here. 1/2 lifetime, the undecayed is equals to decayed. Okay. Here, the next, in this concept, find out the half-life time. I think it is there in chemistry, you know it, Ra? Unda chemistry,
sir.
this part is
లేదు సార్.
No, sir.
so I have to find out here. Simple, as we know, that equation, what n is equals to n naught into e power minus lambda t. Here n I put n naught by 2. N is undecayed, Nana. Undecayed, decayed, both are equal. N naught by 2 is equals to n naught into e power minus lambda into t half after a time of t half. Okay. By this you will get, Nana, what by reciprocating you will get 2 is equals to e power lambda into t half. Apply log both sides, log base e, log 2 is equals to lambda into t half. And therefore, you are getting the equation t half is equals to log 2 by lambda. This is the formula. Log 2 value, I think all of you know. How much is this, Nana?
0.30.
Excellent one. Yavari Medhavi.
0.69.
Yeah. 0, that is log 2 base 10, what you told, 0.3010. But this is base E. Base E means 0.693 divided by lambda. This is the formula to find out T half nano particularly. Okay, you can remember it as a formula, right? Okay, try to remember it as a formula. Then here, sometimes we can use while solving the numericals a small shortcut. Means what I'm writing. Suppose if I fill one table like this, this is the time I'm taking. Okay, and here I'm taking after 1 T half number of nuclei, how much? After 2 T halves, number of nuclei, how much? And so on. After n T half, number of nuclei, how much? In this way, I'm taking the time. Okay, number of nuclei I take here in the below row. After 1 T half, it will be how much, Nana?
N naught by
N
2.
naught. Right. After one more T half, means from here to there, one more T half. N should
N
be
naught.
half of half of
N
this
naught by
value.
4.
N naught by 4.
Half of this value, N naught by 4. Suppose if I write 3 T half here, okay, 3 T half, if I write
N naught by 6.
6 at అదేరా అందుకే నేను కావాలని అడిగింది 6 at
Sorry sir,
అవుతుందిరా.
sorry.
దీనిలో హాఫ్ N naught by 4, మళ్ళీ దీంట్లో హాఫ్ చెప్పాలి కదా,
Yes sir.
అంటే by 2 means N naught by
8.
8.
8. అంటే you are seeing the denominator as power, Nana.
2 to the
1, 2 square 2 cube. 3 T halves 2 power 3, 2 T halves 2 power 2, 1 T half 2 power 1, so on n T halves.
2 power n.
2 power n.
This is one shortcut. If luckily the times they give as the multiples of half-life time, what is say you can use it as a shortcut, Nana. You can. Otherwise, ఏం చేయాలి సార్, already you have the formula in your hand. Use that formula. N is equals to N naught into e power minus lambda. Now is it clear, Nana?
Clear.
All right, good. Leave it. This is one method while solving the numericals. Okay, this is a shortcut. What I said here. Okay, particularly when you are preparing for MSET type of exams, it will be very much useful, this shortcut. Why? Because always they give the time in the multiples of T half. Okay, means suppose example what I am saying, T half of a radioactive nuclei is equals to 4 hours, Nana. And N naught is given as like some 10,000 nuclei. Anukunna. Okay, then they may ask find either decayed or undecayed, anyone. Okay, both we try to find undecayed or decayed nuclei after a time of here say some 12 hours. This is what I'm saying MSET model. Exactly, you look at here, the time he is asking is a multiple of T half.
10,000 by
4
8.
3s are 12. Yeah, 3 T halves means answer directly you can say. Okay, just in fraction of second you can put the answer. Here number of n is equals to directly you can say 10,000 by 2 power 3, that is 8. and decade is, this is undecayed, Nana. That implies decayed nuclei equals to n naught minus n, that is 10,000 minus 10,000 by 8. And you are getting the answer 70,000 by 8. Any wrong in my calculation, Nana?
No, sir.
No, sir.
Right. This is the answer, Nana, here. Now you understood how to calculate?
Yes.
This is what I said. Right, MSET model. Okay. Now we are going to calculate here, not the T half, sir. Okay, we are giving lot of time for it. For what purpose, Nana? Okay, to convert all the nuclei into stable. Means completely transformed, means the number of undecayed nuclei, we are taking it to 0. Okay. Finally, n undecayed is 0. All are decayed. N equals to 0. Then the time taken, okay, to change the undecayed, change into nonsense, to decay the radioactive nuclei from N naught is called, this is called as mean or average lifetime. Mean lifetime or average lifetime. Okay, suppose it is represented with the letter capital T. What is that capital T? He is asking, Anna. Or to avoid confusion, you can take it as TM. M stands for mean. That is your wish. Okay. So here, to find out this T mean, what the procedure I am following here, observe. I am following the procedure. From the mathematics, how to find the average if something is changing. Okay, like exponential means non-linearly. Then suppose if you want average of x, okay, which is given as, suppose x is given as function of, x is a function of say some t or y, something function of t. Then average of x in mathematics, while discussing the integration, they tell one method, that is integral x with respect to, it is changing with the time. So integral x dt, sir, it is given as function of y, sir. Then integral x dy, you write here. Sir, it is given as a function of s, sir. Then x ds, you write here. Divided by integral the variable. This is the method how to find the average number. Okay, you can remember and you can use this formula even in the alternating current chapter in electricity to find out the average EMF and average current. So it will be helpful for you to find out. So here I'm highlighting this box. This is a formula actually from mathematics, just formula. From that formula, I'm going to find out here the mean lifetime. Okay, here what he gave, sir, here they gave number of nuclei changing as a function of time. So here the thing is n is equals to n naught into e power minus lambda t. Okay, but here I am not asking the average n, I am asking average time. Then I write T average, that is Tm. I write it as in the same way. since I'm asking the t, integral t that is changing with n, that is integral t dn by integral dn. Now you understood this step, Nana? From the
Yes,
mathematics
sir.
formula. Do you have any confusion here?
No, sir.
This is the formula I'm going to use here. Okay. According to that formula, next here I'm going to take t average here. That implies Tm is equals to integral t dn. That I write from, better I write that equation first. As we know, here minus dn by dt equals to lambda into n. N is n naught into e power minus lambda t. Correct, Anana? So
Correct.
you can write, right. You can write dn as minus lambda n naught e power minus lambda t into dt. Taking this term to the other hand. That dn I am going to substitute here. That implies t mean is equals to integral t dn. dn is minus lambda n naught e power minus lambda t dt divided by integral dn. No need to substitute this whole thing. Directly I can write it as n, like integral dx is x. Okay. And n already I integrated, so I substitute the limits. From n value changes n naught to finally 0. That I clearly mentioned here. From n naught to n equals to 0. I think you don't have any doubt here. Okay. That n naught is at a time t equals to 0, time limits, and that n tends to 0 after a
Tm.
long time. So that time I take it as
Infinity.
infinity. Long time I take it as infinity. Average, Karnana. Average is t mean.
Okay, sir.
So, if I substitute the limits here at the denominator, I will get 0 minus n naught. That is minus n naught I will get. So minus n naught means negative sign here get cancelled. I will get 1 by n naught in the denominator. And here constants, I will take them out. That is lambda into n naught constant. And you are integrating with respect to time. That's why you can't take these two terms out. So integral, I write 0 to infinity t e power minus lambda t dt. So two variables are there. I think you
By
have to do
parts.
it by parts. So fx gx dx model. Okay.
Yes,
Yeah, that integrate. You can do it already. Integration completed, I think, in your mathematics.
completed.
Yeah. So I think you can do that, right?
Yes, sir.
And finally, after integrating and substituting the limits, this whole value, this part, integration part, I'm saying, you will get 1 by lambda square. Okay. In the evening session, when you are free, try to solve this part, Nana, by the integration by parts. What is it correct or wrong? Once you check 1 by lambda square. That implies T mean is equals to, I am getting 1 by lambda. This is the formula for mean lifetime. Okay. Means disintegration constant is more, quickly disintegrates, so that mean lifetime will be less. If disintegration constant is less, slowly disintegrates, so T mean will be more. Now is it correct, Nana? They are inversely proportional.
Correct, sir.
And last but not least for today, we can conclude that if you see T half and T mean, there will be some relation. T half is equals to log 2 into 1 by lambda. So can I write that implies T half is equals to log 2 times 2 t mean. Any wrong here, Nana? In the formula? Any mistake? Era tappemunda?
No, sir.
No, right. So this is the story what I explained today about the half lifetime and mean lifetime and the disintegration, of course, along with the activity. అంటే ఈ రోజు అంతా డెరివేషన్స్ తో వెళ్ళిపోయింది నాన్న. థియరీ కాన్సెప్ట్ ఈజ్ లెస్, డెరివేషన్ ఈజ్ మోర్ టుడే. సో అండర్స్టూడ్ ఆల్ ద డెరివేషన్స్ హియర్ నాన్న, వాట్ ఐ టోల్డ్?
Yes, sir.
ఏం డౌట్స్ ఏం లేవు కదా హియర్ ఇన్ ఆల్ టైప్స్ ఆఫ్ డెరివేషన్స్?
No doubt, sir. Clear.
Yeah, I am going to wind up the class now, Nana. If you want the pages, you can take. This is the first one. And this is the second one. This is the third one. And this is the fourth one. Okay. Shall I stop the class now, Nana?
Okay.
Bye everyone, Nana. I will meet
Bye,
on
sir.
Monday.
Bye, sir.
Bye
Bye, sir.
everyone. Bye. Nana.